Next, we'll look at some applications of scientific notation questions. One thing that you should be able to do is be able to compare numbers, very similar to the very first lesson of this year where we put numbers in order on a number line. This is the same idea, just that these are numbers in scientific notation. At the beginning of the year, when we wanted to compare real numbers, we changed them all to decimals so that we had a similar number to compare them to. For us, what we'll want to do is compare all of these numbers while they're in standard form. So you'll see three numbers here. The center number is already in standard form. I'm going to leave that one alone. But the top one and the bottom one, I'm going to rewrite in scientific, or in standard notation rather. So the 3.9 times 10 to the 6th, I'm going to need some zeros here. Remember, I usually just put a bunch, and then if I have too many, we can get rid of them. So right now the decimal is here. I need to move the decimal 6 places, 1, 2, 3, 4, 5, 6. So I'm going to need 1, 2, 3, 4, 5 zeros. So this is going to be 3, 9, 1, 2, 3, 4, 5. All right, and then we'll do the same thing with the 4.2 times 10 to the 5th. We'll change it to 4 2s, and we'll put a couple zeros behind. If we have a couple extra, that's fine. We're starting at 4.2, we're moving it 5 spaces. 1, 2, 3, 4, 5. So we need 1, 2, 3, 4 zeros at the end of this one. 1, 2, 3, 4. So then this number would look like this. So my smallest number would be this one, 420,000. Now we do usually like to write them in the original form, so we'll write 4.2 times 10 to the 5th. And then the next two numbers are both in the same place value here. They're both in the millions, 3 millions. So we'd have to go to the next digit. For the top one, it's a 900,000, and the second one, it's an 800,000. So that means the 800,000 is a little bit smaller. So we'll do the 3,800,000 second. And then that means the 3.9 times 10 to the 6th is the largest. Right, and let's look at one more. The other thing we can do with numbers in scientific notation is we can do calculations with them. Add, subtract, multiply, divide. Now if you want to add or subtract them, you'll need to have the same exponent value, so you might have to rearrange them a little bit. For multiplying or dividing, you're just going to use the exponent rules that we used in the last section. So think of this as two separate problems, the part with the plain numbers and then the part with the powers of 10. So 8 over 5 is not going to reduce. I'm just going to leave that as 8 over 5. But then 10 to the negative 3 over 10 to the negative 5. That is our quotient of powers rule. And if you remember that one is the one where you keep the same base and you subtract the exponents. So negative 3 minus negative 5 is positive 2. So we get 8 over 5 times 10 squared. And 8 over 5, if we were to put that into our calculator and get a decimal, that would be 1.6. And then we've got times 10 squared. So you're just going to treat the numerical part the way you always would. And then the powers of 10 part you're going to put into one of your exponent rules and simplify from there. Now one last thing that I want to mention before we move on. Occasionally if you try to use your calculator for some of these things, your calculator might not show you something as a power of 10. So for example, like let's say you had 7.25 times 10 to the 5th and you tried to put that in your calculator. What it might show you instead is 7.25 E5. That is the calculator's notation for scientific notation in many cases. So just be aware of that in case you see that show up.